So when we talk about something's velocity, we can think of that as a vector. It's kind of weird to think of it as vector, but velocity has both direction, right? So velocity has direction and it has a value that goes with it. And so we can think of velocity as a vector. And then the magnitude of velocity is speed. And I don't know if you know this or not, but if you take the absolute value of a velocity function, it equals the speed function, because which is the magnitude of the vector. Speed is always positive, right? When you're driving down the road and you talk about your speed, you never have a negative speed. But velocity can be negative, so that's what we mean by velocity as direction. If I dropped this pin, the rate that it's falling would be a negative velocity because it's falling, but its speed would be that same number as a positive number. So that's kind of the difference between speed and velocity. So most of the stuff that we're going to deal with today is going to be talking about velocity, and you just need to know that the speed is the magnitude of that thing. So just kind of a quick review of what we did yesterday, maybe kind of thinking about it in terms of graphing a bit today. We talked about that if we have these components out here for the vector, that we can say that that's b sub 1 comma b sub 2. And where we ended yesterday is we said we could rewrite those components in terms of the magnitude times the cosine of this angle that's formed, and the magnitude times the sine as the vertical component. So this is the horizontal component, this is the vertical component. Yesterday I drew it over here, and obviously you can see that you can draw that over there as well. And so just to kind of summarize again what we had yesterday, that we can rewrite this is equal to just the magnitude times the cosine of theta times the magnitude times the sine of theta. This is where it's important to note that theta is measured from 0, and that's where, could I give a negative angle? If I'm typing in my calculator a negative angle and its corresponding positive angle, it's the same value. So that's where I think it's okay, as long as you see that we're measuring from 0, whether it's positive or negative. Yes? Say that again. This formula? Yes, it's just the same as saying v1 comma v2. So like giving the order, or that's the same as if we wanted to put the I and the j with it. Okay? So the first example here, not so bad, but it kind of gets us used to the language here. And they give you a nice picture, and then the second one's a lot worse, no picture, and a lot more stuff going on. Right? But let's see if we can, I'm going to focus in on this bearing part a little bit more this time. So it says we have this DC-10 jet aircraft. It's flying on a bearing of 65 degrees at 500 miles per hour. It says find the component form of the velocity of the airplane. Recall, this is kind of really important. It just says recall like you all know this, which if you don't do any navigating, you probably don't know this. The bearing, when it says bearing, it's the angle that the line makes with due north measured clockwise. All right, so due north, that's always going to be right here, right? North. And so the bearing is the angle measured from there. And that other example that we did with something a long time ago, we talked about like measured 65 degrees east of north, right? And that would be the same as the bearing. We would say that's 65 degrees. But what's important for you to know is 65 degrees is not the theta in this formula. So you have to always find, if the bearing's 65 degrees, what's the angle from 0? And so they drew the picture really nice for you on this one. You can see that they just said this is 25, because you can see that you can just take 90 minus 65, and what's left over there would be 25 degrees. And so nice with the pictures there. So if you can recognize that this is your theta, and if you know that the speed of this jet is your magnitude, so the speed is 500 miles per hour, that's our magnitude, all we have to do is write this in component form. Which means all I'm going to do is take my magnitude, which is 500, and multiply it by the cosine of the angle that's formed from 0, which would be 25 degrees. Say that again. Speed is the magnitude of a velocity vector. So if they give you velocity, then its speed is and then this is just going to be 500 times the sine of 25 degrees. And just like I said yesterday, if this were from the unit circle, probably I would expect exact answers. But lots of things are not from the unit circle. 25 degrees is not from the unit circle. So this is just typing this in your calculator to get those horizontal and vertical components. Anybody else want me to throw in one of these? Hopefully we're pretty good at this, just typing it in. So this would be 453. I'll just go 2 decimals. And sine of 25. I got 211.31. And you can kind of think about what this represents. This jet is flying at this angle, right? So kind of like 25 degrees from the 0 up, 65 degree bearing. It's traveling at 500 miles per hour. And so what that kind of represents is this is the horizontal and the vertical components of if I went over 453 miles and up to an 11 miles, right? That would be the path that jet's going on. Does that kind of make a little bit of sense? The vertical. Baseball there. No, not always. There's one about baseball, I think, on here. There's one. Basketball, I'm just kidding. An airplane is flying on a compass heading, which is the same as saying a bearing, of 170 degrees at 460 miles an hour. And then a wind is blowing with the bearing 200 degrees at 80 miles an hour. Part A, find the component form of the velocity of the airplane. Part B, find the actual ground speed and direction of the airplane. That means taking into consideration the wind, because the wind is going to change even if the plane is flying at this speed. If the wind's blowing against the plane, it's going to go slower, right? So first part is you have to be able to take the bearing that they give you and figure out what angle are we really talking about. A little bit harder when it's not in quadrant form. So in second hour today, we spent a lot of time on this. So please tell me if you're confused about this. But this is north. The bearing is always measured from north, and it's always measured clockwise. So if I start here and I measure 170 degrees, I'm almost going to be like this. And in second hour, they said they were crashing. I was like, we're not crashing, we're just heading south, right? Like south is down here, north is up here. This doesn't mean like up in the air, and this doesn't mean dying, right? So, if I measured from here 170 degrees, it's almost going to be down here, because if I measured from here all the way to here, that would be 180, yes? So I'm going to draw a little line right here, and from here to here would be 170. But that's not the angle I use, right? I have to use an angle starting from here. So you have 2 options. One option is you can make the positive angle. If I make the positive angle, I'm going to have to go from here all the way around, yes? The other option is you can use the negative angle. If they're coterminal, then I could just measure from here to here. I like the negative one because I can see it better, but you tell me what you're going to do. So what would the measure, if from here to here is 170, how could I figure out what from here to here is? How'd you get that? Okay. So you said there's 10 left over, so then this is 90 minus 10 means this would really be negative 80 degrees. I was going to say, I don't know how I was thinking about it, but in second hour, what seemed to make the most sense after we spent a long time on it is if this is 170 degrees measured from here, we have to measure from here. So we basically just want to take 90 off of it. So we just subtract 90 from that. What does that get you? But you have to remember that it's negative because we're going in that direction. So it's kind of like you're measuring quadrant 1, but you don't want quadrant 1 because you don't measure angles way up there. Like so. I don't know. Maybe I taught it differently in second. It's weird because we don't normally measure from there. We're used to measuring from here. So it just kind of threw people off. And I didn't emphasize the fact that we were measuring clockwise, so they were upset because they're like, why aren't we measuring like this like we always measure? And we just had some issues. I learned. That's why you're lucky that you get to be in this hour. I learned from all their confusion how to teach you better. So if this is my angle now, and I know that the speed is its magnitude, so the speed is 460 miles an hour, all we have to do for part A is write that component form, which is just 460 times the cosine of negative 80, or if you prefer the positive angle, that would just be 270 plus 10, that would be 280 degrees. I promise it's the same thing. And 460 times the sine of negative 80 degrees. And just like number 1, we're going to get some decimals here. Speed equals the magnitude of the velocity. So if I just go 1 decimal, I would get 79.9. Something else that always makes me feel like I'm doing things correctly is if the values that I get match where I drew my vector. So when I get a positive x and a negative y, and my picture has my vector in quadrant 4, I feel really good because in quadrant 4, not only x and y, but the first component should be positive and the second component would be negative. So at least kind of justifies that I'm doing something somewhat correctly. So if we're going to take into consideration the wind, before we can find the actual ground speed, we need to find the vector for the wind. So same idea, but the wind is blowing with the bearing 200 degrees. So again, think about starting here is your 0. Say it out loud yet, but think about it. Think about where am I going to end up if I go from here and I need to go 200 degrees. 90, 180, plus 20 more, okay? So I'm going to end up over here somewhere, like this. That's going to be my wind. So we're measuring from 0. So the option again is we could go backwards here and measure negatively, or we could measure positively, whichever one you want to do. If you use the way I did this one, again, if we have 200 degrees, you just don't want quadrant 1 in there. So if we subtracted 90 from that, you're going to get 110 degrees. And I think that's what's here, right? Because this would be 90 in this quadrant, and then 20 more over here. So 90 plus 20 is 110 degrees. However you want to see that. But again, because we're measuring this way, then my wind, I have 2 winds here, is going to be 110 in this one. Or if you prefer, you can measure positively, 90, 90, and 70. Questions on where I'm getting those angles from. To me, the weirdest part of these, because we don't usually work with bearings that often. Right, cosine of negative 110 is the same as cosine of 250, so it's whichever one you prefer to work with. So, part B, before I can actually do this, I'm going to find my wind vector. And again, the speed is the magnitude of that vector, so I'm just going to take 80 times the cosine of negative 110 degrees, and 80 times the sine of negative 110 degrees. I'm in quadrant 3. Should it be negative? They should both be negative because my vector's in quadrant 3. So if they're not, then something's wrong. I got negative 27.4. Oh, I did positive 110. That's going to mess things up. And negative 75.2. And again, they're both negative, which at least makes sense with where I do my vector. Questions about that part? So now here's what we can do if I can erase this surface here. I want to find out what the actual speed of my airplane is flying at this this speed with the wind at this speed. And so basically what I'm trying to do is find the result of when I add those two vectors together. So to find the actual ground speed and the magnitude, we have to find the new vector of what happens when I take into consideration the airplane with the wind. So I'm going to double check. I need to go down into your assignment. So I'm going to add the airplane vector plus the wind vector. Yes. I don't know. It seems like that if it was blowing, then maybe? I don't know. I don't know the answer to that. He said if it says it's going with the bearing at 200, so we're adding these two vectors. He said if it said it was going against the bearing, would you subtract instead of add them? Right? Could you just change the... degrees the other way.
It's going 200 degrees.
I don't know. I'll admit. Bearings and vectors are not our So I don't want to say something that's not correct because I don't really know. Let's look what happens when we put this together and see if what happens to the speed compared to the speed of the game. Let's look at that, and then maybe that can make us think more, because I'm just not really sure. So if I add the wind, I'm going to add, or basically subtract 27.4. Then I'm going to take negative 453, subtract 77.2. Negative 528.2. And notice this is in miles per hour, so we're talking about miles here. So that means that if we added those two together, we would somehow be like, think about what I talked about yesterday to do that weird to do. Is this the speed or the angle of direction? This is just my component form, but we did yesterday. If I have the component form of the speed, the wind, and the airplane together, I can find both the magnitude and the direction. I can find the magnitude by just taking the square root of 52.5 squared plus negative 528.2 squared. That's the magnitude, right? So that's going to give me the speed, its magnitude. this is what Jacob's talking about. Because the wind is going in the same direction, right? Because it's going with the bearing, that with the wind, the speed is actually 531-ish miles per hour. So he was asking, what does that mean? Like, what would it say if the wind was going against it? And I just am not sure the answer. I need to find an example problem so we can look at it, because I just don't really know. Yeah. Maybe, what if the vector was just in the opposite direction? I wonder if that was like, if the wind was up here, even if it said going with it, if it was going up there, like, would it slow it down? You think up here would still see that? I'm gonna make. We're gonna end. I'm gonna do some problems so we're gonna figure it out. I don't know. I'm saying I was hypothesizing, not that I know it's true, is that I was saying you always add them, but if the wind was up here, when you add them, would your result be smaller? Is what I'm saying. Like, would the speed actually slow down even if it said with it? I don't know the answer. I want to try this. I don't know. We'll look at it, but I just don't know the answer. The other thing is the direction. And just like you found the direction yesterday, you could do sine, cosine, or tangent. I always do tangent. We're still not done. That's just the speed. We also have to find the direction. This is the speed. This is where applied math is really hard, right? It's easy when they just give you the components already and say do this. It's much harder when you have to draw your own picture and write your own vectors and do all the work to it, and they're ugly numbers. Like, that's why applied math is hard. But tangent, if these are my components, remember I can just take this divided by this. It's like opposites over adjacent. So negative 528.2 over 52.5. Yeah. And so I got the angle to be about negative 84.3 degrees. We were talking to other people about this airplane, and they gave us a problem in bearings. Do you think they want us to say, well, it's actually at negative 84.3 degrees? They want us to say that? No, we need to find the bearing. So we found it from 0 down to here is negative 84.3. The bearing is from north, so I want to measure from here down to here. So how did you get 174.3? Christopher, how did you get 174.3? Because we need to add back this quadrant that we were subtracting out earlier, but we're measuring positively now. So we would add 84.3, and we would actually say that it's the direction with bearing 174.2. That's awesome, right? You saw the notes and you're like, oh, only 2 problems. 2 new, I can still solve. There's a question on the homework very similar to this. This is number 44 from the homework, and I gave you number 43 from the homework. So you should be able to set that up very similarly to that.
So with bearing, so that's like
yeah, so like it was 170 degrees. So with the wind, taking into consideration the wind, it's now with a bearing 174.3. So it's like 4.3 degrees. That could be a real problem on that. I don't know. We'll see. So 43 is like the one that we just did. All right, you're gonna see it looks identical. Just the numbers are different. 42 and 45 are also story problems, but they're not as hard. It's like one thing, like find the component or find the vertical distance or the horizontal. Maybe you don't have to find both. And then 57 through 60 are just multiple choice, more over yesterday's stuff than today's stuff. So there's less problems, and really only 3 of them are story problems. Only 1 of them is a long story problem. But try those because it is, it does show some extent about stuff. And then I'm going to try some different ones and see if you can figure out if it's too. That question. Christopher, why don't you bring your book?